Welcome to Double Your Objects with this one weird trick. Or reduce doesn't have to reduce. So who am I? Just briefly, my name is Paul Galvin. I work at Slalom Consulting in Manhattan. You can see my picture right there. These days I'm blogging at medium.com at PA Galvin, and the source code for this video presentation is up on my GitHub account at Video Examples. So this presentation is about the reduce function in JavaScript, and it has what I think of as being sort of a misleading definition when you think about sort of the way that the world defines it. This particular definition comes from Mozilla, and you can read it yourself. It just says a reduce method applies a function against an accumulator and each value of the array from left to right to reduce it to a single value. So the part that I object to, and I object to it not because it's strictly wrong. In fact, it's not wrong. It's just I object to it is that it sort of creates this expectation in your head that, oh, well, I have to be reducing things down to a single value. And then, unfortunately, the standard example that people give, summing up an array of numbers, kind of firms up that perception, and I don't find that to be helpful. Now, don't get me wrong, summing up an array of numbers is very important, and it's something that we have to do, multiple times a day, usually 2 or 3 times before lunch. So I'm not trying to take anything away from that example, believe me. But it can be used for a lot more than summing up numbers. And that's what my counter example is going to show. So let's flip over to the counter example here. To the canonical example first, and then we'll go to the counter example. Alrighty, so here we are in Visual Studio, and here we have the canonical example. The first section right here is just sort of summing up a simple array of numbers. So we have our numbers array, and we just have 5 entries in it with the number 2. And what we expect to do is that when we execute this function right here, for it to add up all these numbers and give me a 10. It does that by iterating over the numbers array, invoking reduce. Reduce is going to invoke this function against each entry in that array, which is just the number 2. It passes in the accumulation and the current value. So the current value will be 2 in every case since the array only has 2's in it. And the accumulation is whatever we return, which in this case is going to be accumulation plus the current value. So on the first time around, accumulation will be 0 because that's its default. And we add 2 to it. And then the second iteration, accumulation is 2, and we add entry 2 to it and becomes 4, and so on, and we end up with 10. Here's another example where a slightly more interesting number of arrays, where we're starting off with 2, 2, 0, minus 2, and minus 2, and as you would expect, this is going to sum up to 0. So let's go ahead and have a quick look at that, see that in action. And so here you can see we have our two numbers logged out. We have our sum of numbers array, which we're expecting 10, came out to 10 just like it said it would. And then the same thing for our other numbers array, we're expecting 0, and it came out to 0. So good stuff. So now here I've flipped over to the counter example, where I'm going to actually double up some complex objects using reduce. So here we have our source array, and I created some very complicated objects here. Field 1 has a string value, and then field 2 has a string value. And I just did some nice little numbering here so that when we log these out, they're not too hard to pay attention to. So that's my source array. What I'm going to do is I have a duplicated array, and I'm going to invoke reduce against my source array. I'm going to pass in this function. It's going to start off with a blank value. So my accumulator, I should say an empty array. So my accumulator starts off as an empty array, and it's passed in the accumulated result and whatever the current item is. So it'll start off, this is the current item, the next iteration, this is the current item, third iteration, this is the current item. And what I'm doing is I'm taking whatever my accumulated result is and concatenating an array to it, which is kind of like the exact opposite of what you would think of when you think of the word reduce. I'm actually adding to the array. And so my accumulated result now is going to be whatever it was passed in plus doubled twice, 2 times as many objects as what it started with. And so when we log this out in the console, we can see our source array, and then we can see our duplicated array. So let's have a look and see what that looks like. So here we are in Chrome, and if we look at it, here's our original collection. And we have our 3 objects just like you would expect. And each one of them is field 1, row 1, field 2, row 1, and then they're just doubled up again. So we have our 3 rows of data, and they're all there. So now if we look at our duplicated collection here, we can see that we have 6 objects, right? 0, 1, 2, 3, 4, 5. And if we look at it, we can see that the last pair are doubled. They're exactly the same thing times 2. So there you have it. We used reduce to double something rather than reduce it down to a single value. So what is reduce really? So the way I think of it as being a historically aware for each. Basically it's iterating over each item in your collection, and it's doing some math or doing some logic. It doesn't really matter, math or otherwise. And then it's passing that result, whatever result you want, on to the next iteration. So that's what I mean by historically aware. It knows what happened in the past, and then it can use it or not. And so in my counter example, I'm just using it by appending to it. I'm not actually interrogating the result or doing anything interesting with the result, but I know what the result from the last iteration was. That's unlike a regular for each, which is just, each iteration happens in isolation. It's in a box or filter, which obviously just returns back a true or false, or a map, which has no idea what happened in the past. It's just doing some logic. So it's a historically aware for each statement. Other languages call this a fold. I'm not a huge fan of that word because I'm kind of ignorant around where that word comes from. I don't really, I can't picture a folding something like a t-shirt or a towel. So, I'm probably just not thinking of that word correctly. But I do like that word on the other sense because it doesn't make you think it has to reduce down to a single value. So there you go. So if you're interested in some further research, Matthias Peter Johansson's videos got me one of his video on reduce knocked me off my perch a little bit on this and got me to realize that it's more of a historically aware for each than it was trying to reduce things down to a scalar value. That's the link to his playlist, but you may have a better luck just looking up Matthias Peter Johansson on in the Google machine. And then I have my own series on functional programming in JavaScript, and if you just go to my Medium site, then you can look for functional programming, the example series, and you'll find a number of examples. And that's that. Happy programming. Thank you for your time.